Properly calibrated boom sprayers are not just critical to crop health, but also to your bottom line. Considering the expense of chemical pesticides, over or underspraying can be a costly error. With this simple worksheet, you'll be able to see to it that your boom sprayer is functioning as it should and in a cost-effective manner. These are also valuable records that can be used each season to track expenses as well as the effectiveness of a given sprayer or application program. Like most calibration procedures, we'll measure a small sample during the calibration in order to determine the total output over any size area that you might be spraying. First, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information along with the date, location, operator, and equipment being used for the calibration. Take note of the tractor's details, such as the tractor make and model, tractor tires brand, the gear it's being driven in, as well as the RPM. Also, record the tractor tire size and height from the ground to top of tire. And remember to record the sprayer make and model, tank size, and pump pressure. Measure and record the distance between nozzles. The calibration calculations are based on the time it takes to travel a measured course, preferably a level straight stretch. The tractor should be pulling a clean sprayer tank, filled halfway with clean water to represent an average weight load. Measure and mark out the course, and then use assistance to record the time it takes to travel the course once down and once back. Record it twice, then average the 2 times in order to establish a standard time. If the first 2 measured times have more than a 10% differential, it may be necessary to repeat the timing tests. In this test, the time was 67.15 seconds for the first run and 67.65 seconds for the second run, for an average of 67.4 seconds. Next, we'll convert the recorded times into miles per hour and speed in feet per minute as part of determining how many feet per minute are being covered and consequently how much product is being applied at each foot. Calculate the distance in feet multiplied by 60. Then divide that number by the time in seconds multiplied by 88. This will give you your miles per hour number. Then multiply the miles per hour number by 88 to arrive at the feet per minute being covered by the tractor and sprayer. With the tractor in a stationary position, set the same engine RPM used in the timing run. Also, set the application pressure that you normally use and spray water through the boom. Collect spray at the nozzles when all the nozzles appear to have a uniform delivery at the desired PSI. The container should be quickly placed under each nozzle for 60 seconds. As part of the worksheet, you'll find this chart for recording the collected output of material over the previously measured time. Take note of the nozzle and tip sizes being used on the boom. Again, make sure that the sprayer tank has been cleaned and filled with clean water. No one wants to be exposed even to minimal amounts of pesticide product during testing. Record in ounces the collected output for each individual spray head. If the test time is too long for containing the output, cut the time in half and multiply appropriately to determine the output for the full test time. While collecting the water during the timed output, the presence of faulty tips or nozzles will be evident by the amount of fluid being released. If any individual head output indicates a deviation of more than 10% of the average output, it may be time to double-check the nozzle for damage or incorrect labeling and should be replaced. By adding the total output, you will be able to determine the total amount of product sprayed during the measured length. Take the total and divide that figure by the number of nozzles on the boom for an average output per nozzle. Determine 10% below and 10% above average by multiplying the average output by 0.9 and calculate the maximum output by multiplying the average output by 1.1. Replace all of the boom nozzles if the average output measures 15% more than a new nozzle's output, based on the manufacturer's chart or discharge test. Next, we'll measure the sprayer swath width. take measurement of the total swath width of the boom. Then we take the total number of linear feet of row per acre, 43,560, and we'll divide that by the row or swath width measurement to calculate the footage being sprayed in each acre. Next, divide the linear feet row per acre by the number of feet per minute that the tractor travels, based on the earlier time testing. This will determine the time being spent spraying each acre. Multiply the gallons per minute by the minutes per acre figure calculated earlier to determine the total gallons per acre. For this example, 51.28 gallons per acre was calculated as the application rate of the sprayer. Knowing with certainty the amount of product being applied is an important tool for keeping your operation running productively and cost-effectively.